Elements in the periodic table, organizing the elements. In this lesson, we're going to talk about Dmitry Mendeleev. We'll look at what he discovered. Specifically, we'll talk about the work that he did with regard to the periodic table. We'll also talk about what information is shown on the periodic table. Specifically, we'll talk about atomic numbers, chemical symbols, and atomic masses. And those are the three main things that we'll come away within this lesson. And then finally we'll talk about how is the periodic table useful to us, and we'll look at groups and periods in that section. So Dmitry Mendeleev, he was a Russian chemist. He organized the very first periodic table of the elements. He arranged the elements according to their atomic masses, so he looked at different types of elements. He measured their masses, and then he put them in order based on increasing mass. So this is kind of an old rendition of his periodic table that he created. With the information that he gained, he also predicted that there would be new elements discovered where there are empty spaces in his chart. He had a couple of question marks, as you can see here in a second. Question marks here, here, there, and a number of other spots where he assumed that in the future we would be able to identify some elements based on the fact that there were blanks inside of his periodic table. Those elements would just be discovered at some point due to him arranging everything by masses. So what did he discover? By 1869, a total of 63 elements had been discovered. They were previously known elements. A few of them were gases, 2 were liquids, and most were solids. Now it's important to also remember that when we're talking about these things, they are pure elements. So it's not talking about liquid water, which is a combination, it's a compound, so it's a combination of elements. So we're talking about things like liquid mercury, the pure form of an element, and those elements would be in a liquid form, or a gas form, or a solid form. Some elements react explosively when compounds are formed. Some of them react very slowly. So scientists wondered if the properties of elements followed some type of pattern. Was there a relationship between the elements and why they reacted with one another the way they did? Mendeleev discovered a set of patterns that applied to all elements. Mendeleev's work. He knew that some elements had similar chemical and physical properties. So for example, silver and copper both were shiny metals. They were also malleable and ductile. Mendeleev thought these similarities were important clues to a hidden pattern. So he noticed that a pattern of properties appeared when he arranged these elements in order of increasing atomic mass. He found that the properties repeated regularly. So for example, lithium, sodium, and potassium, they showed several common properties. By arranging the elements based on the atomic masses and similar properties, Mendeleev developed the first periodic table of the elements. What information does the periodic table contain? The periodic table contains information about each of the known elements. It includes the atomic number, the chemical symbol, or a name, and the atomic mass for each element. Periodic table. Mendeleev created the very first one. The periodic table is an arrangement of elements showing the repeating pattern of their properties. As scientists have discovered new elements and learned more about atomic structure, the periodic table has slowly developed and changed into what it is today. It is now known that the number of protons in the nucleus, given by the atomic number, determines the chemical properties of an element. The modern periodic table, as you see here in this picture, they are arranged in order of increasing atomic number. So starting up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And the atomic number, remember, gives us the number of protons that that element contains. Chemical symbol. Inside of your notes, you will see the box for gold. With that box, I want you to follow along, and I want you to do the same thing that I do inside of our notes here, inside this PowerPoint. And I want you to circle and identify each thing as I do it inside this periodic table. So chemical symbols contain either one or two letters. So circle the chemical symbol and identify it as a chemical symbol. Some chemical symbols are an abbreviation of the element's English name, while others are based on the Latin name for that element. So obviously AU is going to be based on the Latin name. If it were based on the English name, it would probably be either GD or GO. Atomic number. The atomic number represents the number of protons and electrons found in an element. So inside of your notes, circle the atomic number and identify it as the atomic number. The atomic mass. The atomic mass is the average mass that one atom of any given element has. So the atomic mass is usually found at the bottom. So for gold, it's 196.96. And that information tells us the total number of protons and neutrons that gold has. So it's the sum of the protons and the neutrons. If I know that the atomic number is 79, that tells me there are 79 protons. If I know that the atomic mass is 196, and the atomic mass is the sum of the number of protons and the number of neutrons, I can take 196 and I can subtract 79 from it to figure out the number of neutrons. The atomic mass is an average because most elements consist of a mixture of isotopes. So how is the periodic table useful? On the periodic table, the atomic numbers increase from left to right, as I showed you earlier. Most periodic tables are color-coded, and the color code separates different elements, different classes of elements. In future lessons, we're going to learn about each one of these classes of elements. So for example, metals, nonmetals, and metalloids, they are colored differently inside the periodic table to help separate them. An element's properties can be predicted based on its location in the periodic table. All of the elements that are found in certain columns have the same reactivity or have the same properties as elements that are found under or above it. So it creates a predictability. The predictability is the reason that the periodic table is so useful to chemists. Periods. The periodic table is arranged in rows called periods. So we can see here inside of this picture, there's 1 period, 2, 3, 4, 5, and so on. Inside of your notes, I want you to color each period the same color. A period contains a series of different elements. From left to right, the properties of the elements change in a pattern. Metals are shown on the left of the table, and nonmetals are located on the right. Metalloids are found between the metals and the nonmetals. Groups. The modern periodic table has 7 periods, which form 18 columns. Inside of your notes, I want you to circle each group separately. So the first group here, circle it. The next group, circle it. The group in the center, circle all of these together. And then each one of these groups, circle separately as well. The elements in a column form a group. Groups are also known as families. The groups are numbered from group 1 on the left of the table to group 18 on the right. The pattern of properties repeats in each period, so the elements in each group have similar characteristics. So for example, except for hydrogen, the elements in group 1 are all metals that react violently with water. Group 17 elements are very reactive. And specifically, group 17 elements want to react with elements found in group number 1. Group 18 elements are generally non-reactive. The picture that you see here are the noble gases. And the noble gases are having some electrical current added to them. And you can see that each one of the noble gases, as electrical current is added to them, they tend to glow, much like neon signs.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radar,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, pneumatium, dubsidium, rocanium, copernicium, natrium, flerovium, pentium, livermorium, septium, antimontium, and then we're done.